Hello students. Today we will discuss the topic classification of materials and introduction to semiconductors. In this session we will cover the following contents. We will understand the concept of energy level and energy band. Then we will, based on this energy band, we will briefly classify the materials or solids. Then we will discuss the classification of the semiconductors, their characteristics, their advantages and disadvantages. Let's discuss the energy level for this single atom. Any single atom consists of neutron, positively charged proton, and negatively charged electron. These electrons revolve in a finite path or finite orbit around the nucleus. And this is also called as the shell. K shell, L shell, M shell, and N shell. So these shells are separated and there will be a discrete energy level for each shell. Let's take the example of silicon atom, which has the atomic number of 14. So I have represented the silicon structure in which we have the 14 protons in the nucleus and we have the three shells. In the first shell we have the two electrons revolving. In the second shell we have the 8 electrons and in the outermost shell we have the 4 electrons. The outermost shell of any atom is called as the valence shell, and the electrons present in these valence shells are called as the valence electron. Basically, these are only the electrons which are responsible for your chemical reaction also, right? So, if we talk about the energy level, each electron which is revolving in a finite energy level has its own energy and I have a finite energy. So, the electron which is revolving in the K shell has the finite energy and has lesser energy compared to the electrons which are revolving in the valence shell has higher energy. So it is easy to detach the electron present in the valence shell in comparison to the tightly bound electron in the K shell. So as we move away from the age of the nucleus, the electron energy is increased. Let us also understand the concept of the core, how the silicon core is represented, which will be helpful in understanding the intrinsic and extrinsic semiconductors. So, for the silicon or and germanium atom, both has the same representation for the core. This is how this representation is done for the both silicon and the germanium atom. After discussing the energy level for single silicon atom, let's combine the silicon atoms and understand the concept of the energy band. When many silicon atoms will be combined, each silicon atom will donate or share the electron with the adjacent silicon atom and form the covalent bond. Due to this covalent bonding of the silicon atoms, they form a very tightly bound lattice structures. These large number of lattice structures form the crystal and they interact in a solid material and the energy level becomes so closely spaced that they form the bands. These bands are called as the energy bands. We have the silicon atom surrounded by the four adjacent atoms, and these are the covalent bonds which are formed and become tightly formed structure, right? So if we talk about in terms of the energy bands, this energy goes to first energy band is due to the energy level of those electrons which are present in the first shell of each of the silicon atoms. This N is equals to 2 energy band is formed due to the energy level of the electrons present in the secondmost shell of each of the atom. Valence band is formed due to the energy level of the valence electron of each of the silicon atom. And once these electrons are get free due to the heat or due to the temperature, they reach to a free state, or we call it the free electron. So the energy level of these four free electrons will form a band that is called as the conduction band. So conduction band and valence band, these are the two bands, and the gap between these two bands are called as the forbidden energy gap. Why it is called forbidden? Because no electron should be allowed to have the energy between the valence energy band and the conduction energy band. Right. So if we talk about the in terms of the materials, we have the three semiconductor materials which is widely used in the electronics. That is silicon, germanium, and gallium arsenide. So for the silicon, the energy level is this forbidden energy gap is 1.1 electron volt, while for germanium it is 0.67 electron volt. Although in some literature for germanium it is 0.72 volt also, and for gallium arsenide it is 1.43 electron volt. What do you mean by this energy gap? Means this is much energy required for the electron to reach to the conduction band. So in terms of the conductivity, out of these three elements, which has the higher conductivity? Germanium has the higher conductivity because So let's understand how the materials or solids are classified based on the energy band. Right. So we have the three major classification of the materials. One is conductor, one is insulator, and another is your semiconductor. Basically, conductor in the conductors we have the conduction band and the valence band. They are overlapped and they are very highly conductive to the electricity, and they have the very large number of free electrons. Means there will be a no forwarding energy gap between the conduction band and the valence band. So valence electrons are very loosely bound, and the material which is treated as a conductors are copper and aluminum. If we talk about the insulator part, we have the no free electron available because there is a very large band gap between the conduction band and the valence band, approximately more than 5 electron volt, and it does not conduct electricity at all. So due to this very large band gap, the conductivity, this behave as a perfect insulator, and the valence electrons are very tightly bound. Example of the insulators are glass, rubber, and many more material. Wood is also one of the example. The conductivity in terms of if we talk about the conductivity between the conductors and insulator, we get the third type of material that is called the semiconductor. In semiconductor is that conductor which has the electrical conductivity lying between the good conductor and the insulator. In this semiconductor, valence electrons are comparatively less tightly bound. So for the silicon atom, we have already seen that this energy gap is 1.1 electron volt. If for germanium, it is 0.67 electron volt, and for gallium arsenide, it is 1.1 electron volt, where 1 electron volt is defined as 1.6 into 10 to the power minus 19 joule, or it is comes out to be from this formula, that is work is equals to Q into V, right? So this is complete discussion on the materials. So if we talk about the brief classification of semiconductor, semiconductor has some conductivity between an insulator and the metals, and it also the conductivity of the semiconductor can be increased by addition of the impurity or by the process of the doping, right? So temperature also affect the conductivity of the semiconductor. So many devices are made of the semiconductor, electronic devices we are talking about, notably from silicon and germanium, mostly widely used for electronic circuits. So if we classify the semiconductors, we can classify the semiconductor into two categories, that is intrinsic semiconductor and the extrinsic semiconductor. Extrinsic semiconductor can be further classified depending upon the what type of doping we have done. We have the N-type intrinsic semiconductor and the P-type semiconductor, extrinsic semiconductor. Right. So, to understand the electrical behavior of any semiconductor diode, you should understand the physics of the semiconductor. Basically, you should understand the behavior of the any semiconductor diode. Let us understand the characteristics of the semiconductor. That what is the behavior of this semiconductor? That at absolute zero, it behaves as a perfectly insulator. There will be no conduction. There is no free electron available in the semiconductor. But after increasing the temperature, we get some conductivity, although that was not sufficient. Semiconductor is neither a good insulator nor a good conductor of the electricity. Already we have discussed. Also, the electrical conductivity of semiconductor is between the metal and the insulator. That's why it is called half or a semiconductor. Half semi means a half conductor. Semiconductor has the negative temperature coefficient of resistance, as we have seen that as you will see that the as we increase the temperature, the resistivity will decrease, or vice versa. Normally, the resistivity of the semiconductor lie between this range 10 to minus 5 to 10 to 6 ohm meter, and also the semiconductor can be an element. It may be a silicon, it may be germanium, it may be or compound or gallium arsenide, right? Some of the advantages and disadvantages of the semiconductor. Let's discuss first advantages. Semiconductor devices can be operated immediately after switching on the current circuit devices. Basically, these are the advantages with respect to the vacuum tubes. Right? So earlier, the vacuum tubes require so much time to start. So, in comparison to these semiconductor devices, can be operated immediately after switching, and it also consumes less power in comparison to the vacuum tubes. Also, the no heating is required to emit the electrons in the semiconductors. It has the longer lifespan and almost noise free while operating. It's a good positive point we have with the BJT or in the semiconductor and diodes. Also, the most of the one of the most important feature of the semiconductor is that it will offer a very small size of the semiconductor. Right? You can see every day the device is going to be miniature, right? So this makes the device more portable, and it is one of the most good advantage of using the semiconductor. Silicon is the second most abundant material in the nature after oxygen. So that makes it cost effective for the manufacturing purpose. Less power losses, small size, less weight. Also, it operates on low DC power. This is one of the most good advantages of the semiconductor. What are some of the disadvantages? It cannot withstand for the high power. It has some power limitations will be there. Also, the frequency range of operation is quite not sufficient. We have the limitation on the frequency range of the operation. Also, the power is also finite. We have the limited amount of the output power available. And also the accuracy will be changing. It is a temperature dependent quantity. The behavior of the semiconductor changes with the temperature. So the accuracy changes with the temperature. So this is all about this session. Thank you very much.